Research Center for Advanced Decision Technologies, RCA-DET, a division of Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time, intelligent, and autonomous algorithms. Presents its solution based on OPTEX, Optimization Expert System, Optimization, and Visualization Technologies. IT Solution Framework. OPTEX, the Optimization Expert System, is used as a way of developing and implementing the solution requested by the user. OPTEX is the generative artificial intelligence produced by HI, which manufactures decision support systems for Industry 4.0. For those interested in learning more about OPTEX, we invite you to watch the video OPTEX, Optimization Expert System. The structured mathematical modeling, supported by OPTEX, is integrated as part of these concepts. The final user benefits from all these capabilities, since the algorithms to which he can have access are in accordance with the state-of-the-art of augmented artificial intelligence, mathematical programming plus artificial intelligence, that supports industrial hypothalamus, as the modern form of the decision support systems for Industry 4.0. The video OPTEX, a new vision of mathematical programming, presents an overview of OPTEX.
The goal of OPTEX is: the best way to make software is to have and to do it. The HI approach is aimed to develop mathematical models using cognitive robots, that eliminates the tasks of computer programming, since the robots takes care of this process. This enhancement the mathematical modeling capacity of the professionals and produce error-free code.
Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. As a cognitive robot, OPTEX can produce infinite lines of perfect source code in seconds. There are multiple technologies, software, for the implementation of mathematical models of predictive and prescriptive analytics. Those known as HI, which are marketed in the Western world, can be classified into expert systems for optimization, computer platforms for optimization, programming languages, which can be classified into two types, low-level languages, and high-level algebraic languages, and algorithms for optimization. It can be said that OPTEX is at the top level, as it is based on artificial intelligence concepts, to produce cognitive robots, and integrates with the rest of the technologies. There are multiple technologies, software, for the implementation of mathematical models of predictive and prescriptive analytics. Those known as HI, which are marketed in the Western world, can be classified into expert systems for optimization, computer platforms for optimization, programming languages, which can be classified into two types, low-level languages, and high-level algebraic languages, and algorithms for optimization. It can be said that OPTEX is at the top level, as it is based on artificial intelligence concepts, to produce cognitive robots, and integrates with the rest of the technologies. The models implemented in OPTEX can use multiple technologies, due to the clear division between mathematical model and optimization technology. OPTEX AMPL is the computer platform developed by HI for AMPL users. As a AMPL business partner, HI has linked all its OPTEX's mathematical methodologies and technologies to the development of highly complex mathematical optimization models using AMPL capabilities, to offer to the end user a total, automatic, integration between them. The video presents the solutions developed using OPTEX, Optimization Expert System, and AMPL capabilities. The screenshot presents an AMPL program generated by OPTEX. It includes all files required by AMPL. The screenshot presents SQL connectivity in an AMPL program. OPTEX GAMS is the computer platform developed by HI for GAMS users. As a GAMS business partner, HI has linked all its OPTEX's mathematical methodologies and technologies to the development of highly complex mathematical optimization models using GAMS computer language and utilities, to offer to the end user a total, automatic, integration between them. The screenshot shows a GAMS program generated by the OPTEX artificial intelligence. HI is a business partner of IBM. The video introduces the connectivity of HI and IBM optimization technologies. The IT platforms to be linked are OPTEX Optimization Expert System and IBM CLEX Optimization Studio. The screenshot shows an IBM OPL program, generated by OPTEX. OPTEX Gurobi is the software platform developed by HI for Gurobi optimization users. The video presents Gurobi optimization's connectivity with OPTEX, Optimization Expert System, and the services offered. HI is a business partner of Gurobi Optimization. OPTEX's generative capability includes the production of report-type technical documents, in rich text format, RTF, which help configure the deliverables required by the end user. OPTEX's multilingual capability allows the same report to be generated in different languages by filling in the appropriate tables and templates. The screenshot presents part of a mathematical modeling handbook, with the explicit formulation of the mathematical models. This document is automatically generated by OPTEX, and reflects, without errors, the algorithms implemented to solve the mathematical problems. Information system. The information system will be based on relational algebra. The proposal includes templates for all tables in CSV files, and mounting the files on a SQL server. HI will design, and implement, the metadata model of the information system. HI is not responsible for the database, but they will work together with the user, to validate the integrity, and when possible, the veracity of the data. The fundamental elements of the OPTEX architecture are a relational information system, which integrates two specialized information systems, Mathematical Modeling Information System, MMIS, stores the entire mathematical modeling environment, and Industrial Data Information System, IDIS, stores customer data. The next element is OPTEX, the generative artificial intelligence in charge of interpreting the existing information in the MES, and from there generating all the computer elements that are required for the user to interact with the DSS. Based on Open Database Connectivity, ODBC, OPTEX generates the following elements: visual interface for the user to access the IDIS to maintain and consult it. Interface for mathematical models to connect with the IDIS, generated following the syntax of each optimization technology. This interface is part of the computer programs of the algorithms. Below are several examples of this type of component, based on SQL statements. The screenshot presents SQL connectivity in a AMPL program. The screenshot shows SQL connectivity, in a GAMS program, with the Optimization Information System. The screenshot shows SQL connectivity, in an IBM OPL program, generated by OPTEX. The solutions offered by HI are structured as follows. Optimization Information System, relational information system in which the structures of mathematical models are stored, and industrial data, which are to be read by mathematical models, and algorithms of mathematical models, which can be developed with any of the commercial optimization technologies. This is the working environment of math modelers. The optimization information system must relate to administrative applications, or with other mathematical models, to share data and ensure the consistency of the data being handled. We call this information system an enterprise information system, and it is expected to be the work environment of the end users. At the computational architecture level, OPTEX can operate in a cloud environment, where multiple types of devices can coexist, as presented in the diagram below. All the components of the system can reside in different specialized processing nodes. These are central layer. This could be common to all user organizations. AI modeler, artificial intelligence that is responsible for creating and maintaining mathematical models. Optimization server, high-performance computer for solving mathematical models. Multiple servers can coexist in the cloud, and in the client's offices, and optimization database, database that supports the data of the optimization models, and the run audit system. If necessary, in this layer, a control center can reside, for all services provided in the cloud. OPTEX provides the necessary services, for easy deployment on a cloud server, of the system of models. Multiple servers can be mixed. User layer, communicates with the user's own services, for example, user workstations, ERP server, business intelligence server, and geographic information system server. The traditional, or the first, view of running mathematical models on the cloud is associated with an optimization server, which supports an optimization technology to solve complex problems. But with current communication support, it is possible to visualize a cloud service that uses multiple optimization servers, where each one can have its own characteristics, each of them with its own optimization technology. OPTEX's ability to generate algorithms in multiple technologies, maintaining communications between the mathematical models, in such a way that it is possible to think of a work environment, in which the technology is chosen according to the problem to be solved. Then the user could think of an optimization super server that has installed all the technologies. Information system. Input database. The screenshot presents an OPTEX explorer of the elements of the HighPort information system. HighPort is a set of tactical planning and scheduling mathematical models. It was developed to optimize operations and commercial service of the Puerto de Cartagena de Indias. The shell window contains the master table of terminals, and the tables of relationships between the terminals and ships and keys. The shell window contains the master table of keys, and the tables of relationships between the keys and terminals, cranes, and ships. The shell window contains the master table of cranes, and the table of relationships between the cranes and keys. The shell window contains the master table of ships. The shell window contains the master table of ships, and the tables of relationships between the ships and terminals and keys. Information system database, output, results visualization. OPTEX generates source programs in multiple optimization technologies, connected to multiple databases SQL type. In this way, the user can adapt the IT solution to what he or she considers most convenient. OPTEX connectivity with third-party applications implies that OPTEX will automatically generate the application's database, connecting it to the results of the mathematical model, so that the user can visualize them. If the database already exists, you will simply deposit the results in it, as one more analysis scenario. In any case, the necessary adjustments will have to be made, to ensure that the two databases are fully consistent. The connectivity can be output only, or it can be input-output, when the foreign application allows it. As part of its offering, Hi only offers the standard display generated by OPTEX, but at the user's request, Hi can include the one that suits them best, whether it is already developed or not. Standard visualization. The visualization is limited to querying the results database generated by OPTEX. In a port scheduling model, the screenshot displays an OPTEX explorer of windows for the output of a model. The selected table points to the variable time of entry of the ship to the dock. OPTEX Excel standard visualization. It corresponds to a standard interface developed by Hi, in such a way that all the results are exported to a workbook, or to multiple workbooks, so that the user can consult the results in pivot charts, or in pivot tables. The screenshot features a pivot chart. The screenshot shows a chart created from a pivot table. The image presents a selection of a pivot table in Excel with the schedule of services per key. In a model for scheduling ports, the image shows the different types of visualizations in Excel, dynamic charts, pivot tables, and table format. Custom visualization. Due to the high cost and great functionality that is associated with past generation reports, which are of great help to users, when the client requests, Hi assumes responsibility for linking the results of the models to such non-standard reports. Business intelligence visualization. OPTEX can connect with various BI platforms. The methodology is based on the fact that OPTEX from a configuration of standard dashboards, but parameterized according to each mathematical model, generates the connection files to the BI platform, for example, XML files to Tableau. The screenshot shows a dashboard in Tableau for a model for brewing industries. The screenshot shows a Gantt graphic in Click for a scheduling model for facilities and vessels in ports. IBM Planning Analytics. In addition to IBM optimization technologies, IBM CLEX and IBM OPL, programs generated by OPTEX, in high-level algebraic languages, such as GAMS, Mosel, AIMS and AMPL. And in low-level languages, such as Python and C, may be connected to IBM analytics tools, like TM1, Cognos IBM Planning Analytics. The diagram shows the connectivity implemented. The image shows the access menu in IBM Planning Analytics. Consult the results of a production and finance optimization model for the global supply chain of Beer Express, a brewing industry. The dashboard presents the results of production in a country, in this case Colombia. The dashboard presents the results for the production costs of the countries where Beer Express operates. The dashboard presents the resume of the financial statements by country. Geographic Information System Visualization. OPTEX's connectivity to GIS implies that OPTEX will automatically generate the GIS database, connecting it to the results of the mathematical model, so that the user can visualize them. If the database already exists, OPTEX will simply deposit the results into it, as an additional analysis scenario. The image presents the results of the land use allocation model, used for the optimization of the territorial planning plan of Medellin. As of 2004, the planning horizon covers 16 years, divided into 4 periods of 4 years each. OPTEX generates a map for each period, for each variable, and for each constraint of the mathematical model. In this way, the end user works in the work environment that makes them feel most comfortable. In 2005, the OPTEX, our Sinfo interface was implemented. Currently, HI is working on improving the OPTEX GIS interface to be one of its user standard interfaces. This interface operates as an input-output interface. Gantt visualization. OPTEX organizes the information in such a way as to provide Gantt-type reports, using a platform suitable for this purpose. Mathematical models can be discrete time or continuous time. Below is the visualization through various types of Gantt, generated using IBM JViews. The image shows a Gantt organized to visualize the activities. The screenshot features a standard Gantt, showing the vehicles operating in a mining operation, and the industrial facilities they pass through. The image shows a Gantt organized to visualize the use of resources. The image shows a Gantt organized to visualize the calendar. The diagram presents the connectivity of the elements, or objects, that must be considered when building a digital twin. The main reasons to connect OPTEX with the digital twin are: the mathematical models that are used to visualize in the digital twin, the dynamic spatial behavior, are the same ones that have been used for many decades. What has changed significantly is the visualization medium, which has migrated from reams of paper to digital twins. HI is a company that specializes in mathematical models, and the next step is visualization through digital twins, leaving aside visualization in tables, graphs, or other media, which are already part of the past. The real world, and the data that represents it, must be the same in all the technical digital visions we have of reality: digital twins, SCADAs, mathematical models, ERP, smart metering, GISes, etc. OPTEX already connects to many data storage and visualization platforms. The work for HI is already known. The link to the digital twin will be automatic, independent of the model, and the calculation platform, in the same way that optimization algorithms are handled by OPTEX, on multiple optimization platforms. OPTEX's connectivity to digital twins means that OPTEX will automatically generate the digital twin database, connecting it to the results of the mathematical model, so that the user can visualize them. If the database already exists, HI will simply deposit the results into it, as one more analysis scenario. Alternatively, OPTEX will be able to load the digital twin database to be used as data by the mathematical models. In any case, the necessary adjustments will have to be made to ensure that the two databases are fully consistent. In this way, the control of the optimization models can be carried out by the interested party, from the human-machine interface of the digital twin. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." Thank you for your attention.